Anything you guys say can now be recorded. And, okay. All right, you guys. So everybody posted their discussions. Very proud of you guys. You guys are very good posters these days. To week 15. So the question was, how many of these premium and top 10 ringtones can you guys buy if I give you $15? And again, Emily is not going to go over the $15 because I'm going to hawk all her stuff to have to pay for it. And she looks very nice today. So we cannot. So Alyssa, we've looked at hers, and she posted a very long explanation of what she did. And it looks like she started off with an inequality and then it kind of combined systems of equations. So we can talk about that too. And Emma commented, so good job, Emma. And then what did Emma do? Emma did a little math calculation to come up with, oh, you got exactly $15. So she actually spent the total figures, and she used a table to determine. So nice job, very nice job. And so what did you say, Emma? You said 3 premium and 4 top 10. So Edwin, what did you say? You said, did you do this? Did you say 3 and 4 also? Okay, awesome. It looks like you did the same kind of a thing, like a table. Nice job, Emma. Let's see. So Emma, Edwin, Jazz, what did you say? You did 1 and 9. Did you spend $15 then?
No. Wait.
You did 1 and 8. You did 1 and 8.
Yeah.
So you spent, oh, so there's another way to do it. Emily, you spent $10.50, so you have a little change. Give me my change. No, just kidding. So good, and did you just pick numbers also? Oh yeah, you said you just chose 2 numbers. I didn't read that. My mistake, my mistake. And then Elliot, you came up with, so you figured that 6 plus 9. So you must have chose random numbers too. Okay, yeah. That's good. You guys, that's exactly what I wanted. You did a nice job. So let's look at how we might do this. One way that we could do this, wherever we are here in Schoology. All right, so if we look at a good method for doing this, because you guys are going to be working with linear, oops, there we go, wrong website. Anyway, you guys are going to be working with linear inequalities, so it really helps if you can read stuff and then turn it into an equation. Oops, something's going on here. I'm operating in slow motion for some reason. So if I look at, these are called constraints, what I'm going to write. So first of all, whenever you have a situation, you always want to define variables. So I could define my variables as P for premium ringtones, or T for top 10, or you could do X and Y. But if you look at the question, it says how many premium ringtones and how many top 10. So I'm going to use P for premium. And the question will always tell you how to define your variables. So P is going to be the number of premium, right? So obviously, you guys, I'm doing this mathematically because, you know, I'm the math teacher. And, you know, we're gonna learn it mathematically. And then T is going to be top 10, the number of top 10. Okay, and this is what you guys will be doing when you're doing your linear inequalities and you're writing constraints for your linear programming. So I'm just going to put number of top 10 here. Okay. So the first things first, we've defined our variables. Now we need to write this constraint. We want to buy at least 6 new ringtones. So the number of premium tones, right, plus the number of top 10 has to be greater than or equal to 6. Does that make sense? Mm-hmm. Or no? Or sideways, diagonal? What do you guys think? Okay, it's okay, Edwin, that's good. So the number of premium ones I buy, right, plus the number of top 10 has to be at least 6. Okay, so I wrote an inequality that says greater than or equal to 6. So if I add how many I bought together, has to be greater than or equal to 6. Because it has to be 6 or 7 or 8 or 9, but it can't be less. So I wrote one of my constraints. So I'm going to number that, number 1. And then for number 2, so there's going to be one other thing. It says you cannot spend more than $15. So the premium ones cost $1.50 each, right? So I could do $1.50 times P plus the other ones cost $3 times T, and then I can't spend more than $15, right? So here's my $15. So in this case, I can spend less than or equal to $15. Does that make sense for everybody? Okay, so I basically wrote the same type of thing as I did for number 1, only in number 2 I just changed my main equation. So $1.50 times however many premium ones plus $3 times however many top 10 ones has to be less than or equal to $15. Can't be greater. Okay? So you guys, once you have 2 equations, then it's really easy to solve them. Okay? And so one thing we could do is we could graph these and we could see how many we could buy in the region, and I think I'm going to do that. So what I'm going to do instead of P and T then when I graph, I'm going to say that the premium, we'll just call that X, and the Y I'm going to say for T. And I think I'm going to show you graphically first. How's that sound? Does that sound good? But I need to plug this in, so give me 2 seconds while I run away. I'll be right back. Because now I'm down to only 2%. You guys are taking up all my memory. Hang on. All right, you guys. So we're going to do this. It'll be quicker. Did you guys do systems of equations yet? Have you anyone got to that? You guys are not quite there? You guys are actually pretty good about staying up, actually, in this class. Hopefully that works. Because now I'm going down to 1%. All right, hang on. Oh, sorry, Emily. I'm like closing your thing off. Whack, whack. All right, good. Now my screen is brighter too. All right, you guys, so I'm back. Hello. Right. Where's the thingy? Is it up?
Yeah. Where'd it go?
Where'd it go? Hello, I'm back. Okay. All right, so anyway, you guys, so let's look at a graph actually. So I'm going to show you this cool graph. You guys are going to be so impressed, and it's quicker. And so then you'll be so excited to see it. Okay, so if I go to this Desmos, and I always talk about this Desmos graphing calculator, you guys have seen it before. All right, so remember that we said the number, we called that x plus y had to be greater than or equal to 6, right? We needed to buy at least 6. Okay, so I used x and y instead of p and t just because the graphing calculator can only do that. And then one of them cost $1.50. Wasn't that x? And then plus 3y had to be less than or equal to 15, right? Isn't that what I said? I'm pretty sure. So you guys look at this graph. So when you guys are graphing linear inequalities, this blue line represents the constraint that I have related to cost, right? So anything, and now you guys remember that we're dealing with real stuff, right? So would the negatives make sense? Anything out here in the negative area? What do you think, Jess?
Oh my god.
Just say yes or no.
What was it? Yes.
Oh.
No.
Question is, since I'm dealing with real things, like ringtones, right, and real dollars, would it make sense to look at any numbers in the negative areas?
No.
No. Very good. Thank you.
I said no.
You did say no. I know. And Elliot was shaking his head no, too.
See?
I say no.
We all said no.
You guys all said no. So this x-axis right here, right, x represented, what did we say x was? The number of premium or something? And the y-axis represents the number of top 10 or something like that. So if I want to stay under $15 and I want to buy at least 6 total, do you see this overlapping shaded area right here?
Yes.
Those are my choices. So as long as you guys' answers were either, if they fell in here, then you would have the right answer. So, okay, Elliot, what number did you say?
For what?
For your answer for the discussion, do you remember?
For both of them, for number of premiums and number of top 10?
Uh-huh.
For premiums, I had 4.
Okay.
Chunks. And then for top 10, I had 3.
For top 10, you had 3?
Yeah.
Okay, so let's look at that. I'm going to put a blank page in here. I'm going to put our graph in here, okay, you guys, so we can write on it. Okay, so you said 4 and 3?
Yes.
So if I go over here to, okay, so wait, hang on, let me add a label on here. So x is equal to premium, right? And we said, just so we make sure we're not doing it wrong, y is equal to top 10. Okay. So Elliot, you said 3 premium. No, you said Say it again, sorry, 4.
4 premium and then 3 top 10.
So you are right here. Is that in the solution area?
Yeah.
Yeah, nice job. So your answer counts. Very good. Edwin, what'd you say? You said, so you're right on. Perfect. Emily, what'd you say?
For premium, I got 5 in the top 10.
You got how much? 5.
5.
Okay, so premium 5 and how much for top 10?
1.
1. So you're right here. Are you in the solution area?
Yeah.
Yes, you are. You guys are on the borders, but it's a solid line, not a dashed line, so that's okay. Jazz, what did you say? Are you looking?
Oh, T is on.
Okay, and what'd you get
8.
for premium? 8? Oh, 8. So 8 and 1. So look where Jazz is, you guys. Is she in the solution area too?
Yeah.
She is. And then, sorry, Emma, I know you have an answer there somewhere, but I can't look at the moment. Hang on, let me see if I can go see. Can you guys see what Emma's is? How many did she say?
9 and 6. I don't know.
Emma said, oh, 6.
I think the 9 was.
Oh, look underneath. She said 4 top 10 and, wait, no. 3 premium and 4 top 10. Okay, so Emma, it looks like you said 3 premium and 4. Okay, so Emma, look where you are up here. Are you in the solution area? No. So good, Emma, so good. But you know what, Emma, you did a good job trying to figure out mathematically, and sometimes that's hard. And then what did Alicia say, actually? What did Alicia say? Or here I can go look too.
4 and 2.
4 and 2? Okay, so Alicia said 4 and 2. Is Alicia in the area? Yes. So you guys, graphing it is a really good way, and with linear programming, you're going to be graphing and you're going to look for this overlap region, and then you'll be able to see, like, oh, did my answer fall in here? And then you're also going to determine how can you maximize? What's the most you can buy in order to maximize given the certain constraints? So that's definitely one way to do it. The other way to do it is to, the other way to do it is to make a table if you want, like you guys are doing. And Emma, maybe something just went off on your table a little bit because the table definitely would work. The other way to do it is when you start to use systems of equations, you guys can solve this by doing elimination by multiplication. You could multiply the top equation by a -3. You could multiply that through. That's one way. But to me, if you can graph something, it's really easy to see. And with linear programming, it's all about graphing. So any point in this overlapping region would satisfy what I asked you guys to do. So good job, you guys. Good job. Any questions on that? All right, just to make sure you guys are still with me, in your notepads, put yes if you have questions or no if you don't. Just make sure you guys are all awake, see? Make sure you guys still can use your notepads. Notepads. I just like to see you guys type. Elliot, no. Emma, no. Elliot, you raising your hand?
No.
Okay. I know. I just wanted to know. All right, guys, so here's all we're going to do today. We are just going to understand constraints in a contextual situation, which is really what we just did. Practice writing constraints. We did that. So you guys, here's one thing I want you to do in your notepads then. Just list some examples of constraints that you might find in a business. Think of things that might limit. And if you look at this little square box up here, that might give you some hints of some ideas of constraints. But think of, a constraint is something that limits your production or limits your ability to sell things or limits how much you can make or as far as like manufacture or things like that. So any ideas that you guys have in your notepad. So Emma's off and running. Good job. Okay, good, Emily, good. So you guys are all thinking of constraints. And if you have an economics class, you probably talked about, supply and demand and things like that. I don't know if you guys have had that yet, but if you talk about supply and demand and, there's only so much supply, that is a type of constraint too, People might want to buy 50 candy bars, but if you can only make 10 a day and people want to buy 50 a day, that's a constraint. I don't know if you think of any constraints. Anything that would limit, like think about business, What would limit a business's ability to produce something?
Cool. I don't know.
Okay, yeah, potentially.
Okay, cool. So, I
Elliot,
typed it.
that's what you did. Oh, Jesse, I can type that. That'd be fine. Anything you think of, type that in.
And I'll just go for the title.
You can do it. Elliot, did you type something? Work?
Yeah.
Work? Okay. So I'm going to have you, so Emma, you said money. So money is definitely a resource that can be constrained, right? Just like in our last problem, you only have $15. That's a constraint. Workers, and that is very good too, right? If you only have 3 workers, how much can you, say you had a crocheting business or something, I just make that up. I know you guys all like to crochet a lot, you know? So you have your crocheting business. How many sweaters can 3 workers crochet versus 20, right? Oh, and here's a good example. So are you guys familiar with those Afghan rugs? You know, those really expensive ones that are handmade from Afghanistan and like the Pakistanis and they sit and individually they weave that rug and they spend hours doing it, right? And those are kind of expensive. Like if you guys have ever tried to go purchase one, you know, they can be like $3,000. Probably that's why you've never purchased one because why would you buy a $3,000 rug? Because you guys are thinking I'd rather buy a car. But, you know, if you were going to buy one, it'd be totally expensive. But if you went to Home Depot, you could buy the same looking kind of rug for like 20 bucks maybe. Well, maybe not that cheap, but 100 bucks. But that's because they have manufacturing places that they just spit them through a machine, right? And so they have more resources versus these Afghan ones. They only have 1 worker to do it, and so that's a limited resource, so therefore it's more expensive. Reputation, Emma, good. I mean, if you have bad reputation and it's going to impede your sales, that could be a constraint. That's true. Your product, how many products you have, what kind of products, your location, all those are really good, Emma. Elliot, so work, what do you mean by work? Like
If people don't want to do work, they have to do work.
okay, good. So how many hours they actually will put in, right? How productive they are. That's perfect. That's really good. And then Jaslyn, coworkers. So you mean like as in like disagreements or being able to work with your coworkers, or your coworkers not showing up, like a team project in science or something. That could definitely be potentially, right? And Edwin, no. Oh, what's your first answer? Oh, that was your. Oh, yeah. That was the no. Yeah, no questions. Okay, I'm like no. Not sure I understand that one. But no, yeah, okay. So no is not your answer. Can you think of any resources? Oh yeah, people did take them. This is true. And Emily said the same thing. Time, money, location, all very good. So you guys understand that constraints limit your ability to produce. So that's kind of the key, and that's when you do linear programming, you will find out that it's all based on constraints. So you guys, here's what we're doing today. We're just going to write 4 constraints. You guys write them. As soon as you finish writing them, you can go back into the discussion and you can post to somebody else, and that's your ticket out. So then you can be done.
You can help me, right? Come on.
So I can help you guys for sure. So here's number 1. All you have to do is write a constraint. Use X and Y for every variable so you don't have to think about anything. And I even helped you on number 1. You have to write a constraint that represents you only have enough time to read 3 chapters a day for your English class. And X is equal to the number of chapters that you read per day. So how would you write that as a constraint? So X something.
It's not an equation, it's just x equals a number.
Okay, good, except for you don't use equals, use an inequality sign.
Alright.
So Elliot, you're exactly, yes. So does that make sense, you guys? You're writing an equation, but instead of the equal sign, do you want me to do the first one for you guys?
Yeah, that'd be great.
Okay, because the second one is just like the first one. So I'll do the first one, you guys will do the second one then. Okay. So you only have enough time to read 3 chapters a day, and X is the number of chapters. So the number of chapters you read per day is going to be less than or equal to 3, right? You might read 3, you might read 2, you might read 1. That's it. That's it.
Wait,
I'm confused.
so the answer's in the question?
Oh, well, there's no answer. All we're doing is writing a constraint.
Wait.
That's a constraint.
This is our ticket out?
Well, yes. So I just wrote, basically, you guys, what I did is wrote an equation to represent that sentence.
So the next one will be, okay, like, yes, alright, we get it.
Type it in your box. Like
Yeah,
a
we'll
box.
go through our grade.
Or note pad, or whatever that's called, little note box.
But number 2 don't make it's not a
The
question.
same as no, there is no question, you guys. So none of these are questions. You're just
So just write like
an equation to represent that.
Is that good? Yeah.
Elliot, nice. Yes, yes. Except for we won't talk about it. It's really close.
Really.
You're really really close.
But that's what was in the first
True, but it's like the first one, only they might be a little bit different. Like there's a 2 instead of a 3, or maybe the sign is different. All right, Edwin, what'd you do? Ah, yes. So,
one. Oh. Okay.
Emily, let's see, good. Emma, you're close. Ah, yes, very good. Okay, you guys, I think you all pass on number 2. So you must complete at least 2 practices in your math class to get caught up, at least.
oh I get it.
So that means 2 or more, right? So that means your x has to be greater than or equal to 2. Good job, you guys. Okay, so number 3 is a little bit different. Do you want to try it on your own, or do you want me to?
Help.
3 and 4 are very similar. Okay, how about this?
Oh.
Raise your hand. Oh, Emma, if you want to try it, I know, Emma, you already did all your linear programming, so you might be able to do number 3. Who wants help? Raise their hand. Mm-hmm. Or do you guys want to look at it? How about look at it real quick? And if you need help, raise your hand on your guy, you know, the little thing on the top. Emily and Emma have raised their hands. Okay, all right, you guys. So I'll let everybody read it, and then I'll actually do number 3 with you, and then you guys will look at what I did for number 3, and then you'll do number 4, okay? All right. Edwin raised his hand. Okay, good. All right, so I'm getting a consensus here. Jazz, do you need help then? Elliot,
Oh,
okay.
I don't have to raise.
Yeah, but they raise their hand, so I'm assuming you raise your hand too, because they. Good job, you guys. Raise your hand. Nice job. That's an A+ right there. Okay, so you guys, when you're doing these, think about what it says. So here's a constraint, right? Space. So the store can only hold 500 square meters. That's a constraint, right? So we can't go above that. So I'm going to put 500 down here because I know that's part of my constraint. So what can I put in the store? I can put couches and recliners in the store. So if X is the number of couches, so I'm going to have X couches, but how much space does each couch take up?
48.
Yeah, 48. Yeah, so yeah, 22 is your other one. Good. So 48 square meters times however many couches, plus I'm going to put recliners in there. How many? When you said 22, good. So plus 22 square meters times however many couches. What kind of inequality sign would I need in here then? Very good, Emily, very good. Less than or equal to 500. So all the couches and recliners that I put in here has to be less than or equal to 500 square feet. So 48 times however many couches plus 22 times however many recliners, that'll give me my total square feet, and it will have to be less than or equal to 500. All right, you guys, try number 4. So it's going to be exactly the same. Use X to represent, you know, number of soda cases or something, and Y to represent number of juice cases, something like that. And think about your constraint. One. The feast? Fiona, the feast. Feast or famine. I'm glad you're going to come. Oh, thought you'd come. You're singing? Oh. Oh, you're singing. Tell your mom it's very important for your grade that you have to do a math calculation on the pounds of turkey. You have to do absolute value equation on the food before and after. Oh. No, you didn't. You turned it all in? I thought you didn't want to. See, you said you didn't want to, but really I could tell you wanted to do it. You know, Kim, we actually have PowerPoints, believe it or not. We actually do have a PowerPoint.
I don't know how to sign it.
How the assignment go? Oh, put what your guess is. Did you put a guess in there, Emily? Ah, but very good start. You got the hard part. So you know what? The sign, we'll figure it out.
All right.
And then read it to yourself. Elliot, let me see. Where are you? So you're very close.
My
Emma's typing. Jazz is. Oh wait, Jazz, we got your erased yours. You're like pulling an Edwin now, erasing it before I get to it.
How about that?
Very close. You were maybe closer before, actually.
Really?
Uh-huh.
Isn't that?
Wait, where are you, Jess?
Oh.
Where's your X and Y?
Oh.
Elliot, I'm going to ask you that question. That might be a hit.
Oh, okay.
Where, donde está your X and your Y?
Oh, shit.
That was English and Spanish, by the way, in case you guys didn't know. Okay. Ah, yes. That is much better. Emma, very nice. Elliot, Edwin, good. Emily, you fixed it. Yay. Okay. So you guys are exactly right. So if you do 0.2 hours times however many bottles plus 0.5 hours times, you guys forgot the 0.5 in front of your fives, by the way, except for Elliot. 0.5 hours times however many cases of soda has to be less than or equal to 18 because you can only operate up to 18 hours. So nice job, you guys. And these types of things just require a lot of practice, a lot of seeing it to understand it. But you guys, this will all start to go into your memory, and then when you start to see it in the weeks, it'll be very familiar to you guys. Okay, so as soon as you post a response to somebody's discussion, and you can just type a question, you can type something you learned, you can, you know, do a reflection, and then you guys can go.
Response to the discussion from the first thing that we did?
From the very first thing, yep. Just make sure you post a response. See, and that way your grade, I can grade it right after this, and you won't have to come back and do anything later.
Okay.
And you'll get a grade. Why are you looking at me?
Well, you looked at me first.
Sorry, Jeff. All right, you guys. So I'm just gonna assume since you guys are all in the discussion, then, and Emma, you too. Are you yes, less than or equal to? That's very good, Emma. Yes, yes, yes. Are you guys have any questions before I end at all? Emma, you are typing? Good. Oh, Emma, except for, oh no, I see what you're doing, yeah. Okay. Less than or equal to 18, yes, Emma, that is exactly right. Is that your question? Yes, exactly. Emma, you were typing, and now you are not. But yeah, Emma, your equation is right. It's 0.2x plus 0.5y has to be less than or equal to 18. And that is actually, I think that's what you had. So you're good.
Okay, I'm done.
All right, good post, and you guys are done, and maybe we will see you at your feast. Oh, one other thing that Miss Dorn wanted me to tell you guys. Make sure you do, did everybody in here do their goals?
Oh, I was doing
For
that.
what?
Mr.
Oh,
Schreiner
for
helped.
counseling. For
No.
counseling. Okay, so do you guys know where to go in for that?
Counseling?
Yeah.
Go to there's a counseling course, actually, Edwin. And if you go under materials, you'll see, it'll say ICAP, and you'll have all the different grades go in it for your grade, and then just complete that page. And there's only like a couple things, like you want to go into Naviance and check your goals. You probably have done that like earlier. So if you've already got goals in there, just make sure you still like them. And then there's one thing that Mr. Bush needs you guys to submit, and it's in that goal thing, but you'll see it on that page. But ask me if you need help. I can help you guys.
Wait, so I'm on the counseling page right now. Now where do I go?
Go to materials.
Mm-hmm.
All right, you guys. Well, I'm gonna end the webinar. So bye, Emma.
Bye.
And yes, you did. Awesome, Emma. Awesome. I know you did.